Today, we will be adding two three-digit addends, 377 plus 187. But first, we will estimate our sum. To estimate more easily, we will look for benchmark numbers. So in this case, for 377, we will round down to 350. And for 187, we will round up to 200. Benchmarks are numbers that are easier to work with, and in this case, rounding one addend up and the other addend down will give a more approximate estimation. So we have 350 plus 200 to work with now, but we're going to break it down a little further, or decompose. So I'm going to decompose 350 into 300 plus 50 and bring down the 200. And then we will add up the rest. So we're going to add up the easier ones together to make 300 plus 200, 500, plus 50, which is left over, giving our estimated sum 550. We will begin by modeling our addition equation using our handy-dandy base 10 blocks. I have laid out our two addends, 377, which is equivalent to 3 flats, 7 rods, and 7 cubes, and 187, which is equivalent to 1 flat, 8 rods, and 7 cubes. So there are a total of 14 cubes, a total of 15 rods, and a total of 4 flats. In order for us to make this work, our place value columns can only consist of one digit, so we will have to do some regrouping. We know that 10 cubes is equivalent to 1 rod, and that 10 rods is equivalent to 1 flat. So we can exchange 10 cubes from the ones column and replace it with 1 rod in the tens column. We also need to exchange 10 rods from the tens column for 1 flat in the hundreds column. So 5 flats is equivalent to 500, 6 rods is equivalent to 60, and 4 cubes is equivalent to 4. Therefore, our sum is 564. Now we will solve our addition equation pictorially. Here we have 377 and 187 drawn out using base 10. So we will start in the ones column. We have a total of 14 cubes, 7 here and 7 here. So we need to cross out 10 cubes and exchange them for 1 rod because 10 cubes is equivalent to 1 rod. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I will draw a rod right here. Then we will do the same thing in the tens column. Since we carried over 1 rod to the tens column, we now have 16 rods. We need to cross out 10 rods and exchange them for 1 flat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Flat over this way. Therefore, altogether we have 5 flats in the hundreds column, totaling 500. We have 6 rods in the tens column, totaling 60. And we have 4 cubes in the ones column, totaling 4. So altogether, our pictorial summation is 564. To add symbolically, we will be using the partitioning method. We will take each addend and partition the number into smaller parts to help us find the sum. This method allows the students to be able to solve larger 3-digit numbers, like our equation, by breaking down the numbers in their place value parts. So we will take 377 and partition this addend into 300, 50, 20, and 7. 50 and 20 come from the 70, just easier benchmarks to work with. And for 187, we will take 100, 50, 30 for the 80, and 7. Now we will reorder our numbers into place value parts and combine our addends. So we'll start with the hundreds, 300 plus 100 plus 50 plus 50 plus 30 plus 20 plus 7 plus 7. Now we will begin to solve the actual summation. So we can break it down even further. So 400, 50 plus 50 is 100, 30 plus 20 is 50, and 7 plus 7 is 14. Once again, 400 plus 100 is 500, and 50 plus 14 is 64. Therefore, our symbolic summation is 564. The personal strategy that I will be using is the place value method. Each of these addends has place values. These are the ones, these are the tens, and these are the hundreds. So the ones, the tens, the hundreds. So we're going to add each place value together and then add up all of those numbers to find our sum. We'll start with the ones. 7 plus 7 equals 14. And then we will go to the tens. 70 plus 80 equals 150. And then we will take from the hundreds column, 300 plus 100 equals 400. Now we will add our three sums, 400 plus 150 plus 14. 400 plus 150 is 550 plus 14 equals 564, which is our sum. Lastly, we will compare our original estimation of 550 to our sum of 564. There is only a difference of 14, therefore our estimation was pretty close to our true sum.